In this video, we're going to have a look at how we can solve the values to two unknowns in a system of equations. So notice here on the left, we've got two unknowns and a system of two equations. To solve these unknowns, what we're going to use is we're going to use a rule called Cramer's rule. And this is a really powerful rule in that if we represent our system here as a matrix, we can follow a simple formula and deduce our unknown x and our unknown y in a really easy manner. So consider if we want to change this over to a system of system represented by a matrix, we can say that on the left here we'll have our coefficients of x, so -1 and 4, and our coefficients of y, 1 and -3. And building the rest of the system up, we've got our variable x and our variable y. So if we multiply these two matrices together, we'll get the left-hand side of this expression or this equation. Then on the right-hand side, we've got our constants of 1 and 1. Now with Cramer's rule, what it states is that if we have, say, if we want to find variable x, what we can write is we can write something called the determinant, which we learnt in a previous video. The determinant of this matrix here up top, or down below I should say. So the determinant here, so -1, 1, 4 and -3. And then up top we're going to do something a little bit different. So to get the values of x, we're going to first start with our coefficients of y and put them in here. And then we're going to get our constants. So our constants here, and build them, or build a new matrix up top with the constants located here. And when we evaluate this expression on the right, it'll come out with the value of x. So subbing in the values of 1 and 1, and 1 and -3, we can evaluate this by going, don't need that, 1 times -3 minus 1 times 1, and that's all over -1 times -3 minus 4 times 1. Going down a little bit further, -3 minus 1, and that's divided by 3 minus 4. One step further, we've got -4 up top, divided by -1 down below, and therefore our value for x is 4. Now calculating our value for y, we've got y equals, and we're going to do the same process, but with a little bit of a change. So rather than having this matrix up top here again, we're going to grab the coefficients of x and throw them in here, and we're going to get our constants on the right and from in where the coefficients of y were in this matrix up here, and down below we'll have the same determinant of this matrix here. So putting it all together, -1 and 4, 1 and 1, and then we've got -1, 4, 1 and -3. Evaluating this, we're going to have -1 times 1 minus 4 times 1. And to save myself a little bit of time, rather than doing the determinant of this matrix or this determinant in the denominator, notice I've already done that calculation down here. So I can simply just sub that in there, saving myself a lot of hard work. So in the numerator, we're going to get 1, or -1 minus 4. That's all over 1. And that will come out to -5 over -1. Therefore, the value of y is +1, +5. That's better. Now we can check if we got this calculation right by grabbing either equation 1 or equation 2 and subbing in the values for x and y and seeing if the left hand side is balanced with the right hand side. So I'm going to grab equation 1. So we're going to say negative x plus y equals 1. Then we're going to say let x and y equal 4 and 5. Now putting this all back together, we're going to get negative 4 plus 5 equals 1. And adding the left-hand side, or evaluating this left-hand side expression, we're going to get 1 equals 1. And notice that the equation is balanced. Therefore, we have the right solutions, or we have a set of solutions for variables x and y for this system up here. So this is how we would use something called Cramer's rule to help us solve the unknowns to a set of linear equations.